Limiting factor analysis. A limiting factor or scarce resource or constraint is a resource in limited supply that prevents an organization from achieving the required or desired level of activity. Now, this can be shortage of raw materials, it can be shortage of labor hours, it can be shortage of machine hours. So I'm going to start by giving you an illustration assuming we are producing bags and we need to produce 100 bags. So production of 100 bags. So to produce 100 bags, we need materials and maybe we need labor. So for materials, how much material is needed? So how many kilograms do we require? So required materials, maybe to produce 100 bags, we need a total of 1000 kilograms. Now, for labor, to produce those 100 bags, maybe people need to work for, we can say 80 hours. Okay, we can do 100 hours. So people need to work for 100 hours. But what is available? Now this is what is available. For materials, the available quantity is 900 kilograms. But for labor, the available is 120 hours. Now, what is the limiting factor? If you look at this, you see we need 1000 kilograms, but we only have 900 kilograms. It means we cannot produce all the 100 bags because the material that is available is limited. Maybe there is shortage. Even if we go to the market, there is no material. So that the available material is only 900. Then when it comes to labor, to produce 100 bags, people need to work for 100 hours. But what is available? It is 120. So it means for labor, we don't have a limiting factor. So for labor, no limiting factor. But for materials, there is a shortage. We can't produce all the 100. We need 1000, but what is available is only 900. So here there is a limiting factor. So when do we have a limiting factor? And when don't we have a limiting factor? So there is no limiting factor if available is more than required. It is number 2, labor. You see what is available? We have 120 hours, but we only need 100 hours. It means we can produce all the units. Then a limiting factor occurs when available is less than required. So we look at materials. When we look at materials, what is available is only 900 kilograms. But we need 1000 kilograms. So it means there is a problem with materials. So what is the main aim of this? So if a company wants to maximize profit, what do? They should aim at making as many units as possible by making the most efficient use of the limited resource or scarce resource. So the aim is to make efficient use of the scarce resource. And how do you make an efficient use of the scarce resource? By making a production plan. So you plan, and you plan according to the limited resource. So you plan according to the scarce resource. Now in the exam, you can be faced with 2 exam possibilities. So what are the two example possibilities? It can be one limiting factor or it can be more than one limiting factor. Or what we call multiple limiting factors. So it can either be one or multiple limiting factors, more than one limiting factor. So if it is more than one limiting factor, in all these, the aim is to get the optimal production plan. And how do we get the optimal production plan? So for one limiting factor, there can be two cases, and your aim would be either calculating the contribution per limiting factor. So this is how we get the optimal production plan, or it can be saving per limiting factor. We are going to look at this, but for multiple limiting factor, you get the optimal production plan by using what we call linear programming. So one limiting factor, two cases, it can be contribution per unit or saving per limiting factor to get the optimal production plan. But for more than one limiting factor or multiple limiting factors, the optimal production plan can be obtained using a technique of linear programming. So we are going to start by looking at one limiting factor. We start by looking at one limiting factor. So if there is only one limiting factor, then the production plan must aim at maximizing the contribution per unit of the limiting factor or the scarce resource. Note, it is not just contribution, it is contribution per unit, but from using the scarce resource. This is why we don't use contribution. For example, we are producing two products, product A and product B. So product A has a contribution of 20 and product B has a contribution of maybe 30. Now to produce 1 unit of product A, this is the material that we use. So material per unit, but the material per unit for each unit of A, we are using maybe we can say 2 kilograms, but for B, for each unit, we use maybe 6 kilograms. Now you see, according to the contribution, what would be preferred? The best option would be to produce product B if we don't have enough materials. But I've put for you the material required per unit. So for each unit of product A, we need 2 kilograms, but for each unit of product B, we need 6 kilograms. Now what is the material that is required per unit? It is 2 and 6. Now what if we have 12 kilograms? So what would you produce? What would you prefer to produce? So you see, if you have 12 kilograms, for product B, you can only produce, I think, 2 units. So you divide 12 divided by 6, you can only produce 2 units. But for product A, you can only produce how many units? When you divide 12 divided by 2, you can produce 6 units. But each unit of A gives a contribution of 20. And for product B, each unit gives a contribution of 30. So here you see, for product B, total contribution is 60. But for product A, total contribution is 120. So this is one explanation. Then the second explanation is this. you calculate contribution per kilogram. So what is the contribution per kilogram? So divide 20 divided by 2, you get 10, and 30 divided by 6, you get 5. So this is $10 per kilogram, and this is $5 per kilogram. So you see the logic behind it. Means if you have only 1 kilogram, what is the most efficient use? What is the most efficient use if you have only 1 kilogram? When you use it to produce product A, you're earning a contribution of $10. But if you use it for product B, you can only get $5. So the most efficient use would be to use it for product A. So that is why we calculate contribution per usage of the scarce resource. It is not just this contribution per unit. We don't consider the 20 and the 30. So what is the most efficient use of the scarce resource? Most efficient use. So most efficient use would be, if you're given 1 kilogram, the most efficient use would be to make product A, because you're earning a contribution of 10, but in B it is 5. So we calculate contribution per usage of the limiting factor. Now we look at the steps. So what are the steps? Step number 1 is to identify the limiting factor. And how do you identify the limiting factor? You compare what is available and what is required. Like in the earlier illustration I gave you. Then number 2, calculate contribution per unit of each product, and contribution is selling price minus variable cost. So this is how we get contribution. Then calculate the limiting factor per usage per unit. So it is simply the usage of the scarce resource to produce each unit. You're going to best understand when we are doing the illustration. So next would be calculating the contribution per limiting factor. Then number 4, you rank the products according to contribution per limiting factor. And finally, you produce products starting with the one that gives you the highest contribution per limiting factor, then the second highest, until the scarce resource is used up. So we can look at an example. Okay, before we look at an example, now this is where I come in, because I've also been a student before, so I know how hard it is to remember all these steps. So after identifying the limiting factor, your focus is simply this. Your focus is to calculate contribution per limiting factor. And what is the meaning of per? What is the meaning of this? It's simply, if you have dollars per hour, it means it is dollars divided by the hours. If you have dollars per unit, it means dollars divided by the units. So this one means, per means you divide. So this is going to be contribution divided by the limiting factor. But it is not just contribution, it is not limiting factor. Each of them is per unit. So up you have contribution per unit divided by the limiting factor per unit. So you see, this was step number 2. This is step number 3. So you've combined into one step, which is step number 4. So your aim is going to be 1, calculating contribution per limiting factor. But everything is contribution per, it is per unit. So it is contribution per unit divided by the limiting factor per unit. We have a look at a question, Never forget the exam technique throughout your ACCA. You start by reading the question. So the question is, how many units of each product should be produced and sold in order to maximize the profits in the year? Or it can be set for you in this way: determine the production plan that would maximize the annual profits. Then part B, they want us to calculate the profit. So we read the data that is given to us. So the budgeted data for a company that produces and sells 4 products A, B, C, D is as follows. So they have given us the products A, B, C, D. They have given us the annual sales demand in units. They have given us what we need. We need materials, labor, variable overheads. Then they have given us the selling price and the profit per unit. However, the available direct materials are 70,000 kilograms. The direct labor hours are 6,000 hours. So you see, materials, we have a total of 70 and labor is 6,000 hours in order to produce all those units of A, B, C, D. So what is the production plan? Now our aim is simply one. It is to get contribution per limiting factor. Contribution per limiting factor. And how do we get contribution? Contribution is simply selling price minus the variable cost, we get contribution. So what is the selling price? So if we want contribution of product A, what would it be? It is the selling price of A minus variable cost. But take note of this: variable cost is made up of materials plus labor plus the variable overheads. So total variable cost is material cost plus labor cost plus the variable overheads. Okay, so we said that is how we would calculate contribution. So contribution would be selling price minus variable cost, because our aim is to calculate contribution per limiting factor. So the denominator is contribution divided by the limiting factor. So we need to identify the limiting factor, and that was step number 1. And how do you identify the limiting factor? You calculate what is available and what is required. So the question has given us what is available. So we need to calculate what is required. So the question has given us that for materials, what is available is, we have 70,000 kilograms. Then for labor, what is available is 6,000 hours. That is what they have given us. So we need to calculate what is required so that we compare and we see whether there is a limiting factor or there is no limiting factor. So how do we calculate the total material that is required? How do we calculate the total material that is required? So you see, they have given us the data that for materials, they have put for you here in brackets, we need $2. The payment is $2 per kilogram. But for product A, they have put up here, we paid $6. So what is the meaning of 6? Now 6 is not the kilograms. 6 is what we pay to produce a unit. So to produce 1 unit, we pay $6. But how many kilograms do we need to produce each unit? Now that is the question. So how do we get the kilograms? By dividing. You divide 6, divide by 2. So 6 divided by 2, we get the kilograms. And the answer here should be 3 kilograms. So it means to produce 1 unit of A, we need 3 kilograms. But each unit is costing $2. So the total payment is 6. But we need kilograms. So it is down here. The kilograms available are 70,000 kilograms. So to produce each unit of A, we need 3 kilograms. For B, it is the same. We need 3 kilograms. For C, so we are dividing 5 divided by 2. We need 2.5 kilograms. And finally for D, we need 3 divided by 2. It is 1.5 kilograms. So in total, how many kilograms do we need to produce all those units? So for materials, total materials, it is going to be, we need 3 kilograms, but in total, how many units of A? We need 4,000 units. Then plus for B, each unit uses 3 kilograms, but in total, we need 6,000 units. Then for C, it is 2.5 times 11,600. And finally for D, we need 1.5 times 5,000. So what is the total? So the total would be 3 times 4 plus 3 times 6 plus 2.5 times 11,600 plus 1.5 times 5,000. And the answer we get is 66,500 kilograms. Now that is the total material that we need to produce all those units. What about labor? Labor hours. So how many hours do we need to produce all those units? So total hours. So how do we get total hours? You see it is the same thing they have put for us here in brackets, that each hour is paid at $12. But for product A, we paid $9. So how many hours were worked? You divide 9 divide by 12. Not 12 divided by 9. It is 9 divided by 12. So 9 divided by 12, we get 0.75. So this is 0.75. Then next, 12 divided by 12, this is 1. 3 divided by 12, 0.25. And finally, 6 divided by 12, you get 0.5. So what are those figures? It means to produce 1 unit of A, you need 0.7 hours, which is like 45 minutes. So total hours required if we are to produce all these units up here. So for A, we need 0.75 times the 4,000 units. And for B, it would be 1 times 6. Then for C, it is 0.25 times 11,600. Then for product D, it is 0.5 times 5,000 hours. So the answer we get is 0.75 times 4 plus 1 times 6 plus 0.25 times 11,600 plus 0.5 times 5,000. The answer we get is 14,400 hours. Now you see, what I've done is what is required, but the question told us what is available. So we find out which one is the limiting factor. So we need what is required and what is available. So what is required is what we've calculated for both material and labor. So for material, the required is 66,500, and for labor, the required is 14,400. But what is available? The question gave us what is available. So what is available is 70,000 kilograms, and for labor it is 6 6,000 hours. So which one is the limiting factor? Now you see, for materials, we need 66, but we have more than what we need. So for materials, there is no limiting factor. Then what about labor? You see, we need 14,400, but we have only 6. We have only 6. It means we can't produce all those units. So it means labor is the limiting factor. So here there is a limiting factor, or this is the limiting factor. So labor hours is the limiting factor. So what is the aim? The aim is to make efficient use of the labor hours, efficient use of the available labor hours, which are 6,000 hours. So how do we make efficient use of the 6,000 hours? We said by determining the production plan, and our focus is to calculate the contribution per limiting factor. Contribution per limiting factor. Now we work out so we have 4 products. Products are product A, product B, product C, and product D. Now our aim is to get contribution per limiting factor. And how do we get so? We need to calculate contribution per unit. Because we say the aim is this, aim is to calculate contribution per limiting factor. And what is this? It is simply contribution divided by the limiting factor. And we said everything is per unit, so we need contribution per unit divided by the limiting factor per unit. So how do we get contribution? But contribution is selling price minus variable cost. Selling price minus variable cost. So for A, what is the selling price? So for product A, selling price is 25. It is down here. And what is variable cost? Variable cost is material, labor, and variable overheads. So it is 25 minus total variable cost. And the total variable cost is 6 plus 9 plus 3. So 6 plus 9 plus 3, we get 7. So contribution for product A is 7. So for product A, it is 7. We work out for product B. So for product B, it is selling price 30 minus total variable cost, which is material cost 6 plus 12 plus 4. And the answer we get is 8. So this is 8. We work out for product C, contribution for C. And the contribution for C is selling price, which is $12 minus total variable cost, which is 5 plus 3 plus 1. And the answer we get is 3. Then finally, product D, contribution for product D. Selling price, it is 18 minus total variable cost, which is material cost of 3 plus labor cost of 6 plus variable overhead of 2, and we get 7. So this is 7. So we've calculated contribution per unit. Next, we need to calculate the limiting factor per unit. It simply means the usage of the scarce resource per unit. How much are we using of the limiting factor to produce each unit? So we've identified that labor is the limiting factor. Labor hours is the limiting factor. So what is the usage of the labor hours for each unit? Usage of labor hours for each unit. Now to produce 1 unit of A, we need 0.75. So we are going to take 0.75, 1, 0.25, and 0.5. So it is 0.75, 1, 0.25, and 0.5. Now that is the usage of the scarce resource to produce 1 unit. Now if material was the limiting factor, then this is what we would have taken. If material was the limiting factor, we would have taken 3, 3, 2.5, and 1.5. We would have taken 3, 3, 2.5, and 1.5 as the usage of the limiting factor to produce 1 unit. But in this question, material was not the limiting factor. It was labor hours. So the final aim is to calculate contribution per limiting factor. So we divide these two, and if we divide, we get 7 divided by 0.75, we get 9.33 recurring. Then this would be 8 divided by 1, we get 8. Then 3 divided by 0.25, it is 12. And finally 7 divided by 0.5, it gives us 14. Now the next step is to rank products, ranking but according to the limiting factor per unit. That is why limiting factor per unit, contribution per limiting factor is very important. So you rank according to contribution per limiting factor. So which is the first product? You start with the highest, and the highest is product D. So this is first. It means when we are producing, we should produce product D first, because it is the one that gives the highest contribution if we use the scarce resource. Then next is product C. So this is second, this is third, and finally product B is the fourth one. Now why do we have the ranking? It is simply because the hours are not available. We only have 6,000 hours. So if we are producing, we should produce in this plan. So the next step is to calculate the production plan. Now this means that the product should be produced in this order. So the products should be produced in this order. It is D, C, then A, and B. So we should produce them in that order until the available scarce resource is fully utilized, until the available, in this case it was labor hours, until the available 6,000 labor hours are fully utilized. So what do we mean? Now we can make a production plan, and the production plan is to start with product D. So this is the production plan. Which product are we producing first? It is the one that gives the highest contribution per usage of the limiting factor. So it is product D. After product D, we should go to product C. After product C, we go to product A. And after A, we can finally produce product B. Now for product D, how many units do we need? We need to produce 5,000 units. Then C, 11,600. So for D, we need to produce 5,000 units, but each unit uses 0.5 hours, 0.5 hours. So in total, if we produce all the units of D, the total hours would be 2,500 if we produce all the units of D. Now, why do we need a production plan? It is simply because of this, that the total hours are only 6,000 hours. So by producing product D, we've already produced 2,500. Then we can produce product B. So sorry, product C. It is 11,600, but each unit uses the usage of the scarce resource. Each unit uses 0.25 hours. And if we multiply, we get 11,600 times 0.25, we get to 900. So we can add up that total and we see what happens. But even if we don't add up, okay, we can add to 5 plus 2, 9. It is 5, 4. So we still have some more hours. Then we can produce product A. And for product A, how many units do we need? We need 4,000 units, but each unit uses 0.75. So we produce product A, and it is 4,000 units, but each unit uses 0.75 hours. So if we multiply this, we get 3,000. So you see, when we add up this, the total is 84. And we don't have the 8,400 hours. We only have 6,000 hours. So we can't produce all these units of A. We can't produce all these units of A because what is left? So when we add up these two, we get 5,400 hours. It means we are only left with, I'm working out this now in red because it is where the problem would be. So we are only left with, you subtract 5, 4 minus 6, you get 600 hours. So we are only left with 600 hours. Now within these 600 hours, how many units of A can we produce? So we can call it, it will just be a balancing figure. So we call it maybe A or X. It is A. So units of A, but each unit uses 0.75 is equal to 600. So how many units of A can we produce? So we solve this. So it is 600 divided by 0.75, 600 divided by 0.75, and the answer we get is 800. So A is 800 units. So it means we are not going to produce product B because the hours are fully utilized now. So what is our production plan? Now these are the products: product A, product B, product C, product D. So this is how we are going to produce. So production units. So production units for A, we should produce 800. For B, we should produce 0. For C, we should produce all the units, which were 11,600. And for product D, we should produce 5,000 units. So this is what we are going to produce. Now in some, they can ask you how many units of A should we produce, how many units of B should be produced, or they can even ask you which product will not be produced. So you see it is clearly product B. Okay, now we calculate the profit. So part A is finished. This is the production plan. The plan is to produce 800 units of A, no units of B. Then for C and for D, it is that. So that is part A. And part B is calculate the profit. So how do we calculate profit? Profit is simply, okay, contribution minus fixed cost, we get profit. So I'm using this part here. So profit would be total contribution minus the total profit. total contribution minus total fixed cost. Now the catch is here. How do we get total contribution? Total contribution is based on the production plan, but total fixed cost is based on the budgeted plan, the budgeted. So why is contribution based on production? It is because we've only produced 800 and we can only sell 800. We've not produced any unit of B, so we are not going to get any contribution from B. So we work out the contribution, and total contribution is going to be, so for A, it is 800 units, but each unit gives a contribution of, it is up here, contribution is 7. So each unit of A gives a contribution of 7, then plus the next product is product C, 11,600, but each unit gives a contribution of product C, it is 3, so times 3, then plus product D, we are producing 5,000 units, but each unit gives a contribution of, it is up here, contribution is 7 per unit, so times 7. So this is total contribution, then we subtract total fixed cost. So what is the total fixed cost? We said it is according to the budget. So for A, what was the budget? The budget was to produce 4,000 units. And what is the fixed cost per unit? So you see 4,000 units, but fixed cost per unit is $4. So it is 4 times 400, 4,000. And I think we get 4 times 4, it is 16. Okay, let me put it here. So it is 4,000. I'm using black. So it is 4,000 times 4. Then for product B, even if we are not producing it, what was the budgeted plan? 6,000 units. And each unit we are paying $6. So 6 times 6,000. Then next, product C, it is 11,600, but the fixed cost is 2. So it is 11,600 times 2. And finally, product D. So product D, 5,000 units times 3. So it is 5,000 times 3. So we work out this. So it is 800 times 7 plus 11,600 times 3 plus 5,000 times 7. And the answer we get this side is 75,400. So we subtract 4,000 times 4 plus 6,000 times 6 plus 11,600 times 2 plus 5,000 times 3, 9,200. So if we subtract, we get a loss of 9,200. We get a loss of 14,800. So this is the loss. So take note of this. Fixed cost is calculated according to the budgeted, but contribution is calculated according to the production plan because it is what we are going to sell. Now I think we can look at the saving per limiting factor. Okay, before we look at the saving per limiting factor, the other trick could be this. The question could tell you that, okay, this is the maximum demand. So maximum demand for A, B, C, and D was 4,000 units. B was 6,000 units. C was 11,600 and D was 5,000 units. So that is the maximum demand, but it can also give you a minimum demand. Minimum demand, maybe it could be 3,000 units. This one we need to produce maybe 2,000 units. Then for C we need to produce maybe 8,000 units, or it could be that same figure. We can do 10,000 units. It's okay, we can do 8 or even 5. Okay, 7,000 units. And for D, the minimum is maybe 4,000 units or 3,000 units. Now, if they give you minimum, the trick is simple. Or in some questions, instead of minimum, they tell you that the company already signed a contract to produce these units, a contract to produce these units. Now, the trick is simple. Minimum demand supersedes the production plan. Minimum demand supersedes the production plan. So what we mean is this: before you make the production plan, you must first produce these units. You must first produce these units. So if we produce all these units, how many hours are we taking? So total time for minimum, total hours for minimum demand. We said each unit of A uses 0.75. It uses 1. This was 0.25. And this was 0.5. So we work out this. It is 3,000 times 0.75 plus 2,000 times 1 plus 7,000 times 0.25 plus 3,000 times 0.5. So the answer we get is the total of all these, it is 7,500. Okay, there is a problem. I need to reduce this a bit further. So let me reduce it a bit further by maybe reducing these units. Let me make them 4,000 units. So if I make them 4,000 units, the total would be, it is still more. I want something less than 6,000 hours. So maybe I can make this 1,000 units. So for product A, the minimum is 1,000. And if it is 1,000, the answer we get is 52. We get a total of 5,250. So minimum demand is already using these hours. But remember the total hours available were 6,000 hours. So when we subtract, how many hours are left? We are only left with 750 hours. So you see the trick? We are only left with 750. So you must first produce the minimum, then after, whatever time is left is what you would apportion. So what we would be apportioning would be this. And we do our plan. Our plan was to produce product D. Then after D, we got product C, then product A, and product B. So we are producing now basing on these hours. So if you have a minimum demand, you first subtract the time required for the minimum demand, then whatever is left, you produce according to the plan. So what I've just explained should enable you to do this question, and the answers are here down. So you work out, and the answers are these. So you see the question has a minimum demand. So you first produce the minimum demand, and after that, then you can produce the remaining units. So you have to first serve the contract. Then after that, you produce according to how many hours are left. So you have this question to try out. So now we can look at one limiting factor involving buy or make decisions. So sometimes we can have a limiting factor and we have to decide whether to produce the product internally or to outsource or buy it externally. Now, the same approach will be taken as before. Identify the limiting factor by comparing required and available. Then for products where there is no alternative of buying from outside, you do what we did first. Then for products where there is an alternative of buying from outside, then you have to calculate the saving per limiting factor per unit. And what is saving? Saving is external buying price minus internal variable cost. What we mean is this: maybe you're making product A and product B. If you make, the cost of making is $10, it is also $10. But if you buy from outside, if you're buying from outside, you can buy product A at maybe $12, and you can buy product B at maybe $13. So you see, for product A, when you make the product, you're saving $2. So it is the 12 minus the 10. So saving is $2. And if you make product B, you're saving $3. So you see, which one would you prefer to make and which one would you prefer to buy from outside? So when you're making, you would prefer to make product B because you're saving more. You see, both cost is the same, but when you're buying B from outside, you buy it at 13. So it is better you make product B. But for product A, when you buy from outside, you buy it at a lower price. So it is better you make product A. So that is saving. It is external buying price, the 13 minus internal variable cost of making. It is only the variable cost, not variable and fixed. So our aim is simply this. So your focus would be on calculating the saving per limiting factor, just like what we did in contribution per limiting factor. So what is saving? Saving is, okay, this is saving divided by the limiting factor, but still everything is per unit. So it is saving per unit divided by the limiting factor per unit. So we can have a look at a question. Exam technique, you start by reading the question. So how many units of each product should be made either internally or outsourced or purchased outside if the company is to minimize costs? It could be the opposite. It could be the same thing. They can tell you if the company is to maximize profit. Assuming, okay, we leave the assuming part because it is up there still. So I've just repeated the same question, as you can see. So everything is the same. What is the additional information? It is here. However, so this is the additional information. Everything is the same like in the previous question. However, there is an external supplier who has been found and he can sell product A at 27, B at 32, C at 14, and product D is willing to sell it out at $15. So remember our aim is to calculate saving per limiting factor. So what are the products? We have 4 products: product A, product B, product C, and product D. So what is the saving? And we said, okay, so what is saving per unit? So what is the saving per unit of product A, product B, and product C? So here I'm putting saving per unit. Now you see, if we buy product A, we buy it at 27. If we buy product B, it is at 32, product C 14, and product D, it is at 15. That is if we buy. But if we make the products, what is the variable cost of making the product. And we said variable cost is material, labor, and variable overhead. So it is 6 plus 9 plus 3, it is 18. And for product B, it is 6 plus 12 plus 4, which is 22. Product C, it is 5 plus 3 plus 1, which is 9. And finally, product D, it is 3 plus 6 plus 2, which is 11. If we buy and if we make, so what is the saving? So if we make, how much are we saving? So here it is 27 minus 18, we get 9. Then this is 10. Then 14 minus 9, we get 5. And finally, I think it is 4. 15 minus 11, we get 4. So you see, that is the saving per unit if we make the product instead of buying from outside. So this is 9, this is 10, this is 5, and this is 4. That is the saving. Then what is the usage of the limiting factor per unit? It is the same thing. Labor hours is the limiting factor, and the usage, if we make product A, we use 0.75 hours. We said it is 6 divided by 2. No, it is 9 divided by 12. So this is 9 divided by 12. We get 0.75. 12 divided by 12 is 1. This is 0.25. And finally, 6 divided by 12, 0.5. So this is 1. This is 0.25. And finally, this is 0.5. Now next is to calculate saving per limiting factor by dividing. So this is saving per limiting factor. So when we divide, 9 divided by 0.75, we get 12, we get 10. 5 divided by 0.25, we get 20. And finally, 4 divided by 0.5, we get 8. Now what is the ranking? You see, it is the same process repeated. The only new part was saving instead of contribution. So what is the ranking? Ranking would be C first, then A is the second, then this is the third, and finally D is the fourth. So after having our ranking, then we can make the production plan. So production plan, we start by producing product C, product A, product B, and finally product D. Now why do we have a production plan? It is because the total hours are limited to only 6,000 hours. So we make product C, and product C, the units were 11,600, but each unit uses 0.25 hours. And if we multiply, we get 2,500. 11,600 times 0.25, we get to 900. So if we produce all the units of C, that is the time we take. Then for product A, it is 4,000 units, but each unit, you see it is 4,000 units, but each unit requires 0.75. And if we multiply, we get 3,000. Now you see how many more hours do we have? 29 plus 3,000, we get 59. Okay, before that, we can produce product B. And product B, we need 6,000 units, but each unit uses 1 hour. So you see, it would have been that, but the time is not available to produce all those units. So we are only left with, let me change the color because this is where the problem normally is. We are only left with 100 hours and we need product B. So how many units should we produce? Each unit requires 1 hour. So times product B is equal to 100. It means for product B we can produce 100 units. So what is the production plan? So be careful here, we are producing 4 products, A, B, C, and D. And how are we producing? So this is the production plan. So production plan, you produce where you save the most, and you have to produce product C. So how many units of C are we producing? It is 11,600. Those are the units. Then for product A, we have to produce all the 4,000 units. For product B, we have to produce 100 units, and for product D, it is 0. So this is the production plan. Now, how many units should we buy? So you see, outsourcing or buying plan. So if we are buying, now look at the figures. For A, we need 4,000 and we've produced 4,000. So we are not buying A. Then for B, we need 6,000, but we've produced 100, so we can buy the remaining 5,900 units. Then for C, we need these units and we produced all of them. Then for D, we need to buy all the 5,000 units. So you see, production plan, buying plan. So when we are buying, we buy these units, but when we are producing, we produce what is up here. That's all about one limiting factor. Now you're going to try questions on single or one limiting factor. So we stop here. Thank you.